It should be now. Yep, we are now. Fantastic. Thank you, miss. So we end that one again. Okay. The correct answer was they're faster. Fantastic. That's going really well. So unfortunately, my slides have skipped forward while I was doing that. So let's talk about what we're doing today. We're sort of 2 minutes in. I think a few more people will join us a little bit later. So my key aim today was to talk about revision for physics, about what you should be doing and how you should do it, because people get really confused about revising things for physics and say, I can't remember all of this, there's too many things. So what I'm going to talk about today are just the top three. So physics units, energy stores and transfers, and current electricity, because we've been doing that recently, and perhaps a little bit on waves as well. Okay, now on these slides here, so there's two sets that I'm going to talk about. So the one's called physics revision. What I've put on the next slide is just a list of which slide numbers have got questions that you need to do on them. There are lots of other slides with questions on, and you can answer those ones if it helps you with your revision. But these are the ones that you need to try and do and hand into your teacher. And just to make sure you've got the right slide, so it's easy in Google Slides, you go through and it gives you the slide number down the side. So number 6, 14 and 15 and 21. Those are the ones you need to answer and hand in. And I've given a little description of what's on the slide so that you can make sure that you're on the right one. So if you go to number 6 and it doesn't have equations on it, then it's not asking you to find equations, you're on the wrong slide. Now, these two and these two here ask you to draw something. The best way to do it would be if you drew it on a piece of paper, and if you were able to take a picture with your phone or with your computer camera and add that to the slide. It's better that you draw them by hand, and even if you just write a line to your teacher to say that you did, than that you draw them with a computer, because in your exam you're going to be asked to draw them by hand. So that's what it would be better if you practiced. So the next thing that's really useful is this. Now, oh, hang on, it's gone through two at once. Let's go back. There we go, is this. Now, every time I show this to one of my classes, everyone goes, oh, that's really terrible. Look at the length of that. I can't do that. That's really awful. But then they have a little look for a minute. So for example, distance, extension, height, length, they are all measured in meters. And we knew that already. Everyone knew that in science. And anything with energy at the end, so kinetic energy, gravitational energy, elastic energy, thermal energy, all of those, they're all measured in joules. It's really helpful to you to have a clear idea of some of these important units. So knowing that weight is measured in newtons because it's a force, because people often say that weight is measured in kilograms because that's what they say in shops. If you go in and ask to buy some cheese, they say, what weight would you like? And that's not correct, because weight is measured in newtons. Mass, how much of something you've got, is measured in kilograms. So when you start revising physics, I would strongly recommend that you try to learn some of these units. What I would do is start with this blank sheet and just start with 1 to 17. Don't worry about the ones on the other side for now. Let's start with 1 to 17 and get yourself a blank sheet. Maybe print it out, maybe write 1 to 17 out. And then look at this sheet, have a look at them and say, right, I can do 1 to 10. I can do all of those. I remember what they are. Hide the sheet with the answer on it. Go back to this one and write down number 1 to 10 without looking. And then go back and check, how many did I get right? Brilliant, I got 9 of them right. I forgot gravitational field strength because it was a bit different to the others. Fantastic, okay. Then I'm going to leave that today and I'm going to come back to it tomorrow. And I'm going to get this sheet again and I'm going to see if I can do 1 to 10 again. And that repetition of nice simple things like this will help you remember those really quickly. That's something you can do at home quite easily, is maybe spend 10 minutes learning these things. And actually that's a more important thing than some of the things that I'm going to ask you to turn into your teacher. So if you really want to help yourself for next year, learning some of these will really help, because it gets really confusing if you can't remember any of the units. Now, this is the next thing that you need to do to test yourself. So being able to find the right equation. Now, if you're doing the foundation paper, 9 times out of 10, you don't have to remember all of the equations. Most of the time, they will give you the equations. There will be one question on the paper where they ask you to remember the equation. And normally it's a fairly straightforward equation. And I'll talk about that later. But what I want you to do, this is the first question that I've asked you to fill something in. So it says, what is the equation that links? Now, for those of you who are sitting at home watching me going, well, how am I meant to know that? I can't do that. That's a ridiculous thing. I don't want to do it. Don't tell me I've got to Google all of those. Well, you don't. Okay, so what we're going to do is, when you've got that up there, what you will also have a copy of in your classroom is this physics equation sheet to learn. These are the equations that don't get given to you necessarily in the exam, although most of them will be on the foundation one. So what you have to do is find the equation that links these things. So the first one says weight, mass, and gravitational field strength. So what we have to do is look down our equation list here and find one that has weight, mass, and gravitational field strength in it. And very handily, that one is the first equation on the sheet. So you could write down W equals mg over here. So you've found it. Or you could write down weight equals mass times gravitational field strength, because that might help you remember it better. So what I want you to do is to go through and identify the right equations, just to help you get used to finding them. Okay, fantastic. So that's the first bit of revision that I want you to do. You've probably seen quite a lot of those equations before. Okay, once you actually see them, you think, oh, I remember doing some of these before. The other thing that's on here that we've done before is actually working out efficiency. Now, this isn't one of the things that I've said you need to do, but if you want to practice using an equation, the efficiency equation is on the sheet, you might want to try filling that in. I advise you to do this if you're already working at a level 4, so you're working at the top end of the foundation paper and you know that that's you. I strongly recommend that you also try doing these 2 sheets here. The equation that you will need will be up here. You will have found efficiency, there it is, number 6 and 7, or for this one, you'll have found work done, because there it is, number 2. So if you found those equations and you know that you're working at a level 4 already, that's a 4-3 or higher, you should really be trying these equations, not the extension one, but just these 3 here, and seeing if you can fill in a line all the way across. If you can fill in all the lines, that's wonderful, but just see if you can fill in a line all the way across. Okay, so that's if you're working at a level 4-3 or higher, you really need to try those as well. So at the moment, I'm still just talking about revision, and I'm going to flick through. So the next thing that we have is there are more questions in here. These are exam questions with some answers in them, but we're not worried about those at the moment. Now, this is the next slide that I want you to fill in as part of your revision. Now, these are all over the place. Finding these is really easy, and they're in some of the slides that we've done before. It's really easy to find a list of the circuit symbols you need to know for GCSE. So I haven't provided you one of those, but you absolutely have to know these 11. Absolutely need to know what they are. So for example, some of them are nice and easy. A thermistor, for example, I always remember it because that's the temperature sensor in your fridge. If you've got a fridge that, you know, you hear the fridge click on and off. If you're sitting in your kitchen, you hear it click, there's a whirring noise. That's it cooling itself down, and then it clicks off and it goes silent again because it's the right temperature. And in the back, it's got a thermistor. Some of you might have even got a fridge. Some fridges, when you hold them open for too long, they start to beep at you to tell you that they've warmed up. And that's a thermistor. And the way I remember it is it's a rectangle with what looks like an ice hockey stick with it, and you only play ice hockey in the cold, and that's how I remember it's a thermistor. Some of the others are a bit easy. So a voltmeter and ammeter, they're circles with a V and an A in them, so they're nice and easy to remember. So I want you to find these symbols and either cut and paste them from Google in here, or draw yourself out a sheet. Drawing yourself out a sheet is a really good way to revise things, because by actually drawing it out, you will remember what it looks like much better. And again, how you revise this is the same as before. So what you need to do is to draw them all out, look at them, see if you can find a way to help you remember what they are. So thermistor, ice hockey stick, voltmeter, ammeter, nice and easy. And then, without looking at your sheet, try to draw them all out again, but this time from memory. Look at how many you got right. Really look very carefully at the ones that you found a little bit more difficult. And then another day, try doing that again. And you'll be really surprised about how quickly you can write all of them out, because these are fundamental things. Being able to do that, and if I go back up here, knowing these units, by knowing those things, you will make some aspects of your physics test or exam much easier. It's much easier to be able to do it if you recognize the symbols and you recognize the units and you recognize what you're looking at. It makes the whole thing much, much easier. So far, my tasks for you in your revision are to try and remember units 1 to 17. I am going to test you on these things next week. Okay, so units 1 to 17, and your technique for that is to write them out, to cover it, to try and write out maybe 5 at a time, 10 at a time, and to see how that goes. Okay, and then the same thing down here, to be able to recall those symbols off the top of your head. And it's the same thing. Find them, write them down, take them away, try and write them down from memory, and do that a couple of other times. You also need some definitions. You need the definition of charge, current, and potential difference. Nice, easy things to look up. And going back up here, that's finding the right equation from an equation sheet. Okay, so those are some things for you to practice. Now, the next slide that I said you needed to do before I get on to doing something new, this is some stuff to do with series and parallel circuits. You need to be able to recognize these kind of circuits. Okay, and again, you're being asked to draw them. Now, this is something that it's worth practicing, because it's not uncommon that you're asked to draw a circuit, and there are some mistakes that people make every time. When we draw circuits in physics, we absolutely have to use a pencil and a ruler. The wires are always drawn as straight lines, and they must touch at the corners. If the wires don't touch, it's not a complete circuit. 3-cell battery. So you'll have looked up what a cell is, and a battery is just more than one cell put together. So you need to look up and revise series and parallel circuits, and then see if you can draw them. That's the whole of the revision. Now, that's quite a lot of work for you to do, to try and remember those 17 things there, these symbols here, 3 definitions, and then to try and put the answers on this slide. So next week, I'm going to have a short Google form for you to fill in at the end of your work. And what it's going to ask you to do is to try and remember some of these, some of the symbols, and something to do with series and parallel circuits. So you'll be able to find out whether your revision allowed you to remember something. So I don't think it should take you to find those, to revise that, to find and revise those and to fill in those sheets, really should be about an hour and a half's work over the week. Okay, maybe a little bit more. Now, remembering that we normally have 5 science lessons a week. This is one of them. You're watching the webinar. Fantastic. You spend a couple of hours doing that. It means you've got a little bit of time left to do something else. So for the next 15 minutes, so that's all about revision, I want to talk about something that's perhaps a little bit new, but it is also part of your revision. So hopefully I can change my slide. Fantastic, there it is. So the other thing you're going to find in your classroom is this set of slides here. AQA, GCSE Combined Science, Physics Required Practical Revision. So this is a list of all of the required practicals that you need to have done. And what you need to remember is that every physics paper that you take, about 15 to 20% of it will be about required practicals. And this is something that I find that foundation students do really well on. Sometimes they do better than the students taking the higher, because this is something where if you're sitting there right now thinking, don't really like science and physics is definitely the worst one, and it's got equations, it's got maths, I don't like it. The good thing about required practicals is you can just learn it. You can just learn it like you were learning a poem or some new words in French or something like that, and then repeat it in the exam. And you can actually get some quite high marks by doing it, even if you're not sure that you understand all of the physics. So the one that I want you to concentrate on this week, and this is your piece of work, is this one down here, waves. And that's because we've done waves really recently, and all of our webinars have been mostly about waves. So what you do is you click on there and it takes you through to waves topic menu. Fantastic. So let's talk through this required practical first. So the first thing you do is you click on aims, apparatus and safety. Here we are, waves. Now, I know that any of you that are in my class definitely did this before we left school for lockdown. Some of you might not have seen it. So if you haven't seen it, what you need to do is perhaps have a look at it on freesciencelessons.com. In fact, I'll send, just come into my head, perhaps I'll send your teachers the link to the freesciencelessons.com video so that you can watch it. Although there is a video here too. Now, when I did it in class, so if I explain here, we've got a ripple tank. So a ripple tank is, this is a tank of water here. It's a little tray full of water. Okay, so the dark grey thing is water. And it's got this little wooden rod here that bounces up and down a little bit. It literally just vibrates up and down, and it's attached to a motor, and you can change how quickly it vibrates up and down. And it makes ripples, it makes waves, hence being called a ripple tank. So it's a little bit like if you put your hand in some water and you did that bang, bang, bang like that, and you make ripples go across it, or in a pond, or you throw a stone in a pond and ripples go across. Got a little wooden bar there, it's bouncing up and down, it makes ripples, ripple tank. Now, in this one, there's a lamp. The ripple tank is made of clear perspex, and there's a lamp above it shining it onto the floor. What we do in school is, although our ripple tank is also clear, we use one of those overhead projectors to project our ripples up onto the board, because it's much easier to see them. They say a digital camera, but we used an iPhone, because any phone that's got a slow-mo record on it is brilliant for this, absolutely brilliant, because it means that you can slow the waves down and see them much better. A stop clock and a ruler, okay? So you set it all up, so either your waves are being projected onto a piece of card underneath, so that light is shining through the waves and putting them on the floor, or in our case, we projected those waves using an overhead projector. We put that on top of an overhead projector and we projected them onto the wall. Okay, now sometimes you use a thing called a stroboscope or a strobe. You've probably heard of strobe lighting, flashing lighting, and we don't use a strobe at school because, as I'm sure you all know, flashing lights and strobes can cause people to have epileptic fits if they're predisposed to it, and so we don't use them. We don't use them at school. It's much easier just to do it using an iPhone. So what do we do? Okay, so what we actually do is project those waves onto the board along with the ruler, and then we are able to measure the wavelength. We can literally measure how long our waves are. So that's nice and simple. We can play back our slow motion video and we can measure a distance. Let's say we picked 30 centimeters, and in slow motion, we can time how long our wave takes to go along 30 centimeters. So now we can work out our wave speed because we've measured, and because it's in slow motion, it's really easy to see how long it takes that wave to go because it has the time down the bottom of the video. We can also work out our frequency, because remember we said frequency was how many waves go past per second. Now, if you watch this for real, it's like the waves are going like this. They're going like that. You can't count them. It's like 1, 2, 3, 4, 5, 6. I can't do it, sir. But if you film it on a camera with slow-mo, you slow it right down and count them as you do 1 second and go 1, 2, 3, 4 waves. Brilliant, 4 waves per second. My frequency is 4 hertz. So we can work out frequency by counting them in slow motion. We can work out wavelength by freezing the picture and quite literally measuring it off the picture. And we could measure the speed by timing how long a wave took to go, or we could use our wave equation that we used in another lesson. There is another part to this where we look at stretched string or elastic cord and we set up a standing wave. I don't want to talk about that today. So there is then this fantastic science teacher here who I'm aware is not as handsome as me, even though he's got more hair, from another school. And the reason that I've used this video is it is actually really good because he actually does the practical. And in freesciencelessons.com, they use a cartoon of the practical, whereas this man does the actual practical on the table. So you can see what it looks like when it's set up. And that's going to be really useful for you. So the last thing I want you to do is this. So I want you to try, because everyone in foundation says, oh, 6-mark questions, can't do them, they're really long. This is brilliant, this one, because all 6 marks for this are plan and investigation to show how a student could make measurements and work out the wavelength of the waves in the ripple tank. So all you have to do is to go back through here and have a look at that video, a look at the equipment list in here, and then write out how you would do it. So the first thing you have to do when you see a 6-mark question that says plan and investigation is, I would use this equipment, and write down what you're going to use. Instead of a digital camera, we used a phone. So I want a ripple tank, I want a stop clock, a ruler, and a camera. Okay, that's everything I need. The low voltage power supply is great to add, but you don't need to, because a ripple tank normally comes with that. So the first thing you do is write it down. You might, if they've already given you the diagram like that, you could then say, and I would set it up like in the diagram, or I would set it up like that, but instead of putting it on white card, I'd put it on the board. I'd shine it on the board. And then you need to describe what happened. Well, to do that, I want you to watch the video and to try and put it into steps, because I've got the answers afterwards. The answers are there. So key points to include: equipment. So you need to put that equipment in. And then it says it could be. There are lots of different ways you can answer this. But the way that we did it was we determined it by finding the time for several waves to pass a point. And we did it by filming it and slowing it down. So what I want you to do is to watch this video, to use the equipment list at the beginning, and see if you can write an answer to how to do this. This is the other half of the piece of work that I want you to do, and to just do it on a blank slide and to turn it into your teacher. Even with the answers there, some people find this difficult to do because the answers are in there, but it says lots of different ways you can do it. I want you to write your own method. And the method we used, remember, was we projected the waves, we filmed them, we slowed it down and counted how many per second for our frequency. We slowed it down and counted how long it took one to go 30 centimeters to work out our speed. And we froze the frame and we measured the distance between 2 waves to work out our wavelength. Okay? Or we used our wave equation. You can watch this bit of the video back again and again. I really want you to practice writing, I would use this equipment. Step 1, I would set it up like it is in the picture. Step 2, I would use my phone to record slow motion the waves that were projected onto the board or the card. Step 3, and to say what it is that you want to do. Step 3, I would count how many waves went past in 1 second. That's my frequency. Step 4, so this is what you need to be able to do. Now, let's see who's been paying attention, because I haven't done a poll since the very, very beginning. So I've got a few polls to go past here. So I was talking at the beginning about units. let's see if you can remember the units of mass. I said that this is something that was quite a problem when you go to buy things in the shops. There we go, and we're off. Someone's voted. Let's see if some more of you vote. Fantastic, we're going well here. Okay, mass, remember, was how much cheese I was getting. How much cheese am I getting? I go into a shop, I ask for some cheese. I nearly said the number there, and that would have given it away. What mass of cheese? Okay, doing well. I'm going to give it another few seconds. I think that'll do. So this one's a bit split. Now, people always get mass and weight and kilograms and newtons confused. So the answer to this one was kilograms. Mass is in kilograms because it's how much. Mass is how much of something you've got. Okay, excellent. But I'm really glad that you knew it was one of those two. And that's at the beginning of the list of units to learn. So the other thing is, last week we were, those of you who were here, we were looking, oh no, that was electromagnets last week. But there are some things that are really odd in our equations. So for example, one of the things I've set you to do is to look at series and parallel circuits. And one of the problems with that is we need to know an equation that's called Ohm's law. And it's that the potential difference is the current times the resistance. Potential difference is current times distance. The problem is the symbols we use in equations are really irritating, which is why you should look at them, because the symbol for current just doesn't make sense. Now, I know this is probably a guess for lots of you, but in an equation, what symbol do we use for current? Can anyone remember? So current is measured in amps. So there is, brilliant. I'm actually really impressed because we've got lots of different ones coming in now, but first person in definitely got it right. So if you hit that button in less than a second, you can feel fairly confident that you were correct. No one else wants to vote? Not sure. It's I. Now, why did I ask you that question? The reason I asked you that question is because even though I've told you in foundation, you don't need to learn all the equations, what you do need to do is make sure that you recognize them on that equation sheet, which is why I've asked you to go through on slide 5 there and find the right equations, because sometimes you get really surprised by what the symbols actually are for something. So I for current just doesn't make sense unless you've seen it before. So there's another one. So we talked about work done at the beginning, and work done was one of those sets of equations that I wanted you to find. But I'm not going to launch that poll actually, because yeah, it won't make sense for you. Okay, so that is exactly half an hour. So I need to summarize what it is that I want you to do. First thing I want you to do is to go through and answer the questions on those 3 sets of slides on the physics revision thing. Find those things, okay? Find the right equations, find the symbols, draw series and parallel. That's the first thing. Second thing, try and learn the first 17 sets of units and try and learn those 11 symbols for drawing circuits. So 3 sets of slides, learn those 17 things, learn those. If you are then feeling confident or you have more time, try and answer this 6-mark question here about how to do a ripple tank experiment. Watch the video, it makes it much clearer. Read the apparatus list and just see if you can write a step-by-step guide. This is really good practice for all practicals. It's really common that they say, your 6-mark question is plan an investigation that. And all you have to do is say, I would choose this equipment. Step 1, I will do this. Step 2, I will do this. Making sure that you say what you're going to measure each time. So I hope all of that helps. Now, the reason that I've been talking about revision is that next lesson, I said, or next webinar, I'm going to have a Google form for you to fill in that's going to test you on those things I've asked you to try and remember, those 17 units and those symbols. The week after, there's going to be a longer Google form for you to try to look at everything that we've talked about in these webinars. So to look at waves, to look at energy, and to help you try and revise and remember those things. So I'm going to revise waves and some other things next week, and I'm going to give you a short Google test on those things. So that's the end. That's your half an hour. I can see I've got a fair few people. If you've got any questions, please hang around now and type them in. Otherwise, thank you very much for coming. And these slides will be in your Google Classrooms by the end of today. Okay, so thank you very much. I can see we haven't got any questions. So unless you've got a question to ask, you need to drop out now. Otherwise, I will just have to drop you out of it. So just start removing people. All gone. Oh, Sir Miss.
Oh, there. That was good.
Wow. 0 question.